Hi, this is Presh Talwalkar. In this video, I'll describe a mathematical way to split a cake fairly. Imagine a cake is to be split between two people, blue and red. There are many different ways that blue and red can split up the cake. Imagine blue makes the offer to cut the cake into two pieces and then choose one of the pieces first. Naturally, this is not a fair offer. Blue is tempted to cut the cake into two unequal pieces and then take the larger piece for himself. So this is not a fair way to split the cake. How can we get to a fair way? The procedure for two people is known as I cut, you choose. That would mean that blue cuts the cake, but then red gets to choose which slice first. Now if blue cuts the cake into two unequal slices, red is going to pick the larger slice, leaving the smaller slice for blue. So this in turn is going to change the way that blue cuts the cake. You can see that blue is going to want to cut it to be 50-50. Let's prove this mathematically. Imagine that x is the fraction of the pie that goes from 0 to 1, or it's a percentage 0 to 100%. So blue cuts the cake into two slices, x and 1 minus x. Red is going to pick the larger of the two pieces, written as the maximal function of x and 1 minus x. This will leave blue with the minimal of the two values, x and 1 minus x. Now blue wants to get the largest piece possible, so blue is going to look at the graph of x and 1 minus x being minimal, and then choose the largest value of this graph. You can see that if any value of x is less than 1/2 or more than 1/2, the value of the graph is going to be less than 0.5. So blue can get the most value by picking the value of exactly 0.5. So blue is going to want to solve by cutting the two slices into exactly 50-50. This leaves blue and red getting 50% of the cake each. What would happen if we had three people cutting the cake? How can we divide the cake fairly? What we're going to do is we're going to divide up the first slice by what's known as the last diminisher method. Blue is going to cut a slice of the cake, and it can be any size that blue wants. Now red is then going to inspect the slice, and red can reduce the slice if red wants. So let's say red cuts the slice and then attaches the remaining part of the cake together. So now this is the slice that red has cut. Finally, green can look at that slice and say, well, I can reduce it a little bit more too. So let's say green reduces the slice. Now the last person who cuts the slice is the one who's going to get that slice. So what is that going to do with the incentives when we look at how blue and red are going to cut the cake? Well, if blue or red actually make a cut to less than 1/3, then blue or red, no one's going to want to cut the cake after that. So the person who cuts it to less than 1/3 is going to end up with less than an even split. So no one's going to want to make the slice too small to begin with. But on the other hand, blue or red are not going to want to leave more than 1/3, because if they leave more than 1/3, then green is just going to cut a very sliver of a slice and then get more than an even split. So blue or red are actually going to do their best job to make sure the slice gets to be about 1/3, and that's why the first slice is going to be basically 1/3, and it's going to go to whoever cut it last. So let's suppose that red makes it exactly 1/3, and then red gets the slice. So now we have a situation where blue and green still need slices of the cake, and there's 2/3 of the cake left. So how can we get two people to split up the remaining 2/3 of the cake evenly? Well, we've already solved that problem. We have blue and green play the I cut, you choose procedure for two people. So let's say blue cuts the cake, and then green gets to choose first. As we've just shown, this is going to result in a 50-50 split of the remaining cake. So now blue and green end up with also slices which are 1/3 each. So now we've cut the cake into three different slices, and three people have shared the cake evenly to be 1/3. This last diminisher method can be generalized if we have even more people. It works inductively. Person 1 first cuts the slice, and then the people after that can inspect the slice and decide whether to cut off a little bit. The same rule applies that the last person to cut the slice is the one who's going to end up with it. the procedure is going to give the incentive that the first slice is going to be getting to 1 over n of the cake. We then repeat the procedure after that one person gets the slice, and then the remaining people are going to use the same method to cut the next slice. And for the very same reason, the next slice is also going to be 1 over n, and so on. We keep repeating this until there are exactly 2 people remaining, at which point they do the I cut you choose method, and they are also going to end up with 1 over n of the cake. So this is the mathematically fair way that you could split up the cake between any number of people. I hope you liked this video. Please subscribe to my channel. I make videos on math and game theory. You can catch me on my blog, Mind Your Decisions, which you can follow on Facebook, Google+, and Patreon. You can catch me on social media at Presh Talwalkar. And if you like this video, please check out my books. There are links in the video description.